The students, today I will discuss with the electric lines of force. Now, what is electric lines of force? Electric lines of force is that suppose in a given region or space, electric field is present. Now, to represent that electric field pictorially or graphically, you have to take the help of the electric lines of force. So, electric lines of force represent they represent electric field. They represent electric field. What they represent, that is real, but they do not exist really. Clear? Exactly what is the actual meaning of this electric line? Suppose you see, suppose there was empty space and the charge is located here. Source charge is located. It will create electric field. Clear? Now, in the field of the source charge, when you bring another test charge, a small positive test charge is placed inside the electric field of this your source charge, then this small positive charge will free to move inside the electric field. Now, the path along which this unit positive test charge will move, now that path described is called electric lines of force. So what I am going to say, in a field of the source charge, when a small positive test charge is placed, then it is free to move inside the electric field. Now the path described by this unit charge or unit positive charge is called electric lines of force. Now this electric lines of force can be straight, can be curved. Clear? If there is a single charge, then the lines of force are straight. Just like your positive isolated positive charge, the electric lines of force is radially outwards and they are ending at infinity and they are straight. And likewise for the negative charge, the electric lines of force are also straight because this is the single charge. So for the single charge, it is straight, and for the positive charge it is radially inward, and for the positive charge radially outward, and for the negative charge radially inward. Clear? If there is system having the two charges, then the lines of force are curved. The lines of force are curved, and it starts from positive charge and ends on negative charge. That's why they are called discontinuous smooth curve. They are called discontinuous smooth curve because this starts from positive charge and ends on your negative charge. There is no lines of force from negative charge to positive charge. Now this lines of force is a straight line or curve on which at any point, take a point P, and if you want to draw a tangent at that point, then that will give the direction of electric field. So what I am going to say, tangent at any point on any electric lines of force will give the directions of electric field at that point. And due to this reason, these two electric lines of force never intersect each other. If they were to cross, then two tangents could be drawn at the same point, which will give the two directions of electric field, which is not possible for a point. That's why two electric lines of force never intersect each other. Now, wherever there is field, there is electric lines of force, or you can say wherever the electric lines of force, there is the field. Inside the charged conductor, since the charges are residing on the surface of the conductor, so there is no electric field inside the conductor. So that's why electric lines of force never pass through the conductor. They meet the conductor normally. Now another property is that here, suppose a system having two opposite charges, then what happens? Now you see it starts from positive charge, ends on negative charge. So you see, if suppose the negative charge were absent, then what will be it will tends to tends to terminate at infinity. Clear? But due to the presence of negative charge, the length of the lines of force will tend longitudinal contract, means lengthwise contract. Clear? Lengthwise contract. Okay. Now this lengthwise contraction property will tell you about the attractive force between the two dissimilar charges. Suppose you have two similar charges, then there is a property called lateral pressure of this electric lines force tell you about the repulsive force between the two similar charges. Clear? And in a given region of space, if the lines of force are crowded, then you can say this is your strong electric field. And in a given region of space, if the electric lines of force are not crowded, then that is called weak electric field. So what I mean to say, that concentration of electric lines of force will give the direction. Concentration of electric lines of force will give an idea about your strength of the electric field. More the concentration, stronger will be the electric field. Lesser the concentration, weaker is the electric field. So this is all about the electric lines of force and their properties. Now we go to the next section, electric dipole. Di means two. Here pole regarded to the electric charges. So suppose I will locate minus q at A and plus q at B, and O is its center. Let they are being separated by the distance 2a. Now what is electric dipole? A system of combination of two equal and opposite charges separated by a small distance. A pair of equal and opposite charges. Why they are called equal? Because their magnitude is equal, magnitude is same. And opposite in nature because one is negative charge, another is your positive charge. If they are being separated by a small distance, then this is called electric dipole. Now the line joining the charges is called axial line. And you see midpoint of the dipole is called the center of the dipole. Here in this figure, the O is the center. If a line passing through the center of the dipole and perpendicular to the axial line, this line is called equatorial line. Clear? Now this electric dipole, to measure the strength of the electric dipole, there is a vector quantity called electric dipole moment. The symbol is your P, and this is a vector quantity. And the direction of this electric dipole moment vector is from negative charge to positive charge. Now negative charge to positive charge. Now how can we define this electric dipole moment? Now electric dipole moment is a vector quantity whose magnitude is the product of the distance between the two charges and magnitude of each charge. Clear? And as I said, 2aq, so this unit is your Q, coulomb, and 2a is your meter. Very careful students, While writing this coulometer, big C and small m you have to write. If you write unknowingly or knowingly MC, then it will be millicoulomb, or it will be both will be small, then it is centimeter. So this will not be allowed. Clear? So coulomb meter. Clear? So electric dipole is a system of two equal and opposite charges separated by a small distance. The line passing through the two charges is called axial line, and the line passing through the center of the dipole and perpendicular to the axial line is called equatorial line. To measure the strength of the electric dipole, we need a vector, that is called electric dipole moment vector quantity. The electric dipole moment vector quantity is directed from negative charge to positive charge, and whose magnitude is the product of the distance between the two charges and magnitude of each charge. Clear? And under what condition we can say that ideal electric dipole? For ideal electric dipole, now the distance between the two charges is your 0 and magnitude of each charge tends to infinity, which is a hypothetical concept, no doubt, but this is called ideal electric dipole. Clear? When you talk about the net charge, what is the net charge or the total charge on electric dipole, then you can say it will be 0. Clear? So this is about your electric dipole. In next class we will study the axial and equatorial point. On axial point and equatorial point, how can you find out the electrical intensity on this electric dipole? Thank you.